All right, so we are going to solve this rational equation right here. So as with any rational equation, before you can solve, we need to clear the fractions because I don't want to solve an equation with fractions. So we have to find the common denominator. So step one is any denominators that need to, I'm going to factor them. So I'm just going to, if you don't mind, instead of rewriting everything, I'm just going to factor everything right under here. These are trinomials. Go back and review factoring trinomials. But x squared plus x minus 6. The two factors of x squared are x and x. The two factors of negative 6 that add up to plus 1 are plus 3 and minus 2. X squared minus x minus 2. I've got x squared as x and x. The two factors of negative 2 that add up to negative 1 are negative 2 and plus 1. And finally, x squared plus 4x plus 3. X squared is x and x. The two factors of 3 that add up to 4 are 3 and 1. And remember, for our rational equations, the common denominator is one of every factor and then the highest power if there's powers. Now, I don't have any powers here, so I'm just going to take one of every factor. So my least common denominator, my LCD, I see that I need a factor of x plus 3. I need a factor of x minus 2. And then I need a factor of x plus 1. And there's just an x plus 3 and an x plus 1, so I have included one of everything that I see. So now, what I want to do with my equation is I want to take my common denominator and I want to multiply it by each fraction so that all of my denominators go away. Now this is going to get a little messy, so I apologize. I've got a small whiteboard right here. But what I'm going to do, the way I like to write my work, is I'm going to write this common denominator next to every fraction. So right here, I'm going to have an x plus 3, an x minus 2, and an x plus 1. And then for this fraction, I'm going to have an x plus 3, an x minus 2, and an x plus 1. And then for this last fraction, I'm really going to have to squeeze it in here. I've got an x plus 3, I've got an x minus 2, and then an x plus 1. Now, to make this a little less cluttered, I'm going to erase my common denominator right there. And now what I'm going to do is I'm going to go about the best part of the business, and I'm going to clear the fractions. So notice, this first fraction is 2 over x plus 3, x minus 2. So now what happens is the x plus 3's cancel, and the x minus 2's cancel. And what I'm left with is 2 times x plus 1. Plus, now the second fraction, I've got 1 over x minus 2, x plus 1. So the x minus 2's cancel, and the x plus 1's cancel. And I'm left with 1 times x plus 3 equals, and on the last fraction, I have 4 over x plus 3, x plus 1. So the x plus 3's cancel, the x plus 1's cancel, and I'm left with 4 times x minus 2. And as should happen with any rational equation, it's going to turn into one of two things. Either a linear equation like this, or a quadratic equation, which has an x squared in it somewhere. Linear equations, our process, get all the x's on one side, all the numbers on the other, so we can divide. So here we go. I'm going to distribute. So I've got 2x plus 2. Then x plus 3 is equal to 4x minus 8. I'm going to collect some like terms. 2x plus x is 3x. 2 plus 3 is plus 5. I'm going to bring my x's over to the left and my numbers to the right. So I'm going to subtract the 4x from both sides. And then I'm going to subtract the 5 from both sides. And so here's what I end up with. 3x minus 4x is negative 1x. The equals stays in the middle. And then negative 8 and negative 5 is negative 13. And when I divide, I end up with my x value is 13. Always remember, for any rational equation, you want to make sure your answer is in the domain. So the question is this number, does it make any of my denominators 0? Well, x plus 3, 13 plus 3 is 16. 13 minus 2 is 11. 13 plus 1 is 14. It does not make any of my factors 0. So this is my solution. I'm going to put it in some squigglies, and there's my solution set. The set with the number 13.